Hello, everybody. I just wanted to point out here then with the pumping lemma. So when we say pumping lemma, this is where we will begin to run through this actually. So for the pumping lemma, this is the concept to prove wherein we have to prove specific language if it is a regular language. So that's our goal in here because in we know that DFA can only have a limited number of states, but sometimes a DFA can have many loops, and that loop means the language is infinite. So what I'll begin to deal in terms of pumping lemma, if a DFA with n states accept a string of length over the n, the language is infinite, or there will be a loop that will gonna happen for that. So idea of looping is exactly what the pumping lemma will begin to pumping lemma builds on. So repetition in our DFA. That's the goal of pumping lemma. Because in pumping lemma, we will begin to check if this is really acceptable or not. So suppose that in your pumping lemma you do have the string as x, y, z. So the x is actually the prefix, and this will be your the loop begin will matter, and then the z will be the suffix. So in our pumping lemma, there will be a three conditions that we'll begin to base with. So under the conditions for that one is the x, y, and n. So this one, y is within the first n symbols, finite state limit. So our y, we can have one y within the first n symbols. So for example, you do have a n and bn. So if n is equals to 2, because you'll begin to set that actually there must be a set of length. So it will become a and b. So for dividing this into three parts, because we'll divide it into x, y, z. So suppose that this will be your x and this will be your y, and this will be your z. So we'll begin to deal with that later on, how it will be represented. Now, after, excuse me, the conditions, and the second, this is the first condition, and the second condition that we'll begin to run through is the loop is greater than 0. The y part must include at least one real symbol, something to repeat. So it could be, this is the condition earlier for the first one, at least in the first set, and the second, it could be not AABB. We can also say that it could be this y, the y, and it could be x, z. So we can say like that. Now, for this one, we can also say here that the possible split for the number 2, that's how it must work. Then for number 3, the condition for number 3 is x, y, I, z for all I greater than or equals to 0. You can repeat y until number of times say in L. If the language is truly regular, we should be able to repeat y any number of times, and the string still will be in L. So that what does that mean? If, for example, if we begin to loop already, so we begin to loop y, it will become, for example, y loop as 2. So we can, no, we can also look that for y1 will become a, b, then a, b, b. So does that still acceptable in this language? It is not anymore. This is not a regular language anymore. So that's how it will be represented in your pumping lemma. So pumping happens to the part of y. You can repeat y any number of times, including 0 and so on and so forth. We'll begin to provide a specific example later on. So the first, excuse me, how to prove a language is not regular using the pumping lemma. We prove this by contradiction. So assuming that the language L is regular, so suppose L is equals to A and Bn here, that's what we have mentioned, we'll test the assumption. So according to what we have discussed last time, N is equals to 3 will become A, then B, then that's the sequence that we're able to have as time. So we can divide that based on this one. It could be in the first set in the prefix one, at least one, or at least one for the at least one for the middle or whatsoever, as long as it's valid. So we can also say A. You can just say that the x possible split, we can split at least one A. We can split two A and one B, for example. We can do that. Um, for this one, we wanted to prove that into Y1. So Y1, we'll just have to loop it. It's your X, Z, and Y. We'll have to loop the A. So this will be the loop. So 1, repeat as 1. So that's um, 4 times 1. We'll just begin to, excuse me. Okay, if 0, start with 0. For 0, we will just remove that actually. 0. So just like this, it will become ABB since this will be removed. And the AN and BN is not a regular anymore. So if Y is equals to 1, it will become as A and AAB. So BB, so it's still irregular. Then next one, if we begin to times that Y is equals to 2, that is A and AAB, then BB. So this is not regular anymore for the A and BN. So therefore, this one is not a regular language. So in our quiz last time, we were able to have AN, BN, and CN just under our quiz last time. So for this one, for example, we do have N is equals to 4. So we actually assume that this is a regular language, as you have mentioned last time. So afterwards, we're able to do A, A, then B, then C. Now, we can also say that in your XYZ, you can your X will become, we can also say A, then your Y, because we can just first, at least the first step rule, at least one in the prefix in the first set. So Y is A, then Z will be B, C. Example like that. So if your Y is equals to 0, it will become, mm, it will become A, um, then A, remove this direct with this one, B, B, C. That's how it works. Now, for Y is equals to 1, it will be, you can copy A, A, B, 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 C, C, C. So that match. So check, wrong, and then y is equals to A. Since our quiz is actually 0, 1, 2, 3, 4, right? 4. Now A, A. So the one na. And then it will become B, 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 and C, C, C. This is wrong. And 3, A, then 1, 2, 3, then B, 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 C, C, C. So this is still not regular. 4, 1, 2, 3, prefix, and 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3. So this is still not a regular. So therefore, this language is not a regular language, not irregular for the pumping lemma. So if ever this is for the first that is for the first condition that we do have. What about for the second condition? Um, that any for the A, B, 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 C, 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 your A is one of A and one of B, you can just say. So X is equals to A and A, then Y will become A, B, then Z will become B, 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 C, C, C. So what can we do? Y is equals to 0. We can remove AB, A. So it will become B, 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 C, 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 C. Then it will become A, B, 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 C, C, C. For 1, for 2, then A, B, C, no, B, C, C, C. 3 is A, B, then B, and C. So number 4, A, A, B, and B, C. So therefore, this is not valid, this is valid, this is not valid, not valid, not valid. So this is not valid regular language. This is how it works for the pumping lemma. That is really so basic. So hopefully that you were able to learn for that one. Thank you so much and goodbye.